back for some maths. As you can see, we're adding fractions, and hopefully you've already spotted the mistake. If you haven't, if you're unsure, if in doubt, draw it out. So my first fraction, I'm going to draw some pizzas, or some circles, into thirds, because the denominator's 3, I'm going to shade in one piece. Then, this fraction, still thirds, because look, they've got the same denominator, I need another 2. So I've shaded in my extra 2, and I could do separate colours, couldn't I, to show kind of 1/3 and then 2/3 and the 2 fractions. And you can clearly see, there's my answer. It's out of 3, and I've got 3 pieces. So again, we've made that common mistake where we've just added everything together. We've put the numerators together and the denominators together, and actually, if we were to draw a picture of what this looked like, so there's thirds, I'm going to half them. If I'm actually going to shade in 3 out of 6, you can see actually, that's half, whereas we've had the whole thing. So not only is the fraction incorrect, it's way smaller. So it's really important, denominators stay the same, and we add the numerators together. So in fact, we should have had 3 and 3/3. So 3/3. So 3 is the numerator, 3 is the denominator. And you will also recognise that as one whole. And you can see there, because we've had one whole pizza. It might also be the case, so we'll do another one. This time we'll have 6. Because you might not always need to draw it out, but it is a good strategy. So denominators need to be 6. That's the first thing I'm going to put in, because the denominator stays the same. And then we're adding the numerators. 2 and 3 is 5. And you could draw pictures to represent that. But what happens if we have an incident where the numerator is bigger than the denominator? Well, we could have 4/6 add 3/6. So same again. Denominator stays the same, but 4 and 3 is 7. And we know that's an improper fraction. Well, if we're unsure, we'll draw it out. So 1, 2, 3, 4, 5, 6. And I'm going to shade in 7 pieces, because it's got to be out of 6. 1, 2, 3, 4, 5, 6. I can't shade in anymore. So I must need a second one. They've still got to be into 6 pieces. But this time I'm already at 6. I need 7. I just need one more. So there, 7/6 actually is equivalent to, and we would prefer to write it as a mixed number, 1 whole and 1 additional 6. Mathematically, we can also think about how many 6s or how many of the denominator go into the numerator. And it's 1 with 1 remaining, 1/6 left over. So that's how we can convert. Do try and have your answers represented as mixed numbers. If you know how to get the denominator into the numerator without doing the drawing, that's fine, but it is always better to draw it out. And you can see there, I've shown really good understanding, really good clear maths there. So it's not necessarily showing you don't know what you're doing if you're doing some working out. I would always advise you to draw it out. So have a go at those 3 questions, pause the video, and then we'll go through some answers. Okay, let's go through some answers. Hopefully you were patient enough and you drew them out. Into rectangles or into circles or whatever shape you like, as long as the pieces are equivalent. But the first thing I'm going to do is put the denominator in, because I know it has to be 8. Stays the same. And then 4 and 3 is 7. And you could have had some nice representations above it. That would have been really good to see. Here, denominator needs to stay the same. It's 10. And then we've got 8 and 7, or 7 and 8, because we can use that kind of commutative law. But when we put them together, actually, it's bigger than 10, and we should know it's bigger than 10. So we have 15. So actually now, we've got to represent that as a mixed number. We'll think about how many 10s go into 15. It's 1 whole. And then how many remainders have we got? We've got 5 left over. 5, but those 5s are tenths. Or again, if we're unsure, show that these are all equivalent. We could have just drawn pictures. So the same as before, draw a shape into 10, shade in as many as you can. If you've still got some remaining, draw another shape into 10, and then you need to work out how many holes you're left with, and then the remaining fraction. And here I've got an example where actually I've got 3 fractions because we can add multiple ones together, but they're all sevenths, which is good. And then we've got 1 and 3, which is 4, and then 5 and 6. That's a nice one to represent. So have a go at making your own questions. Keep the denominators the same, and if you get to improper fractions where the numerator's bigger, that's fine, you could leave it there, but the extra step is being able to convert it into the mixed number. And if you're unsure, draw a picture out and show a representation.